Thank you. I'm Ivan. I'm from Infinum, from Croatia. And from the sense of this title, you sense a fear. And when I started working for Android, everyone in my team, including myself, was afraid of animations, mainly because it was not our main focus. So we were focused on building the applications, building the functionalities, getting more and more features in there. And design was something else we'll do later. Building animations was something new for everybody. So it was time-consuming to learn new stuff and to get a grip of that. So everybody has a fear of that. And you need some motivation to break that fear. I recommend you search that motivation. And this is a good TED Talk from a man who went blind during a spacewalk. So when you hear his story, I hope some of your fears will lose its power. Our eyes are amazing and fascinating instruments. And we get crazy amount of data just from our sight. So what happens when you lose that information for a brief moment? You could potentially get confused, and you don't know what's happening around you. What you want to see, actually, is everything that goes around in your environment, so you can react to it. Probably get rid of these flies. And you want to apply this in your applications. You don't want your users to be confused and not know what is happening in your app. And the first advice I can give you is just start working on that. You cannot get anywhere if you are sitting on your hands. And if you don't have inspiration for that, you can always try and do the animations from the applications you're using every day, like this one. And really start simple. Don't tackle some huge and complex animation when you're doing that for the first time. And gradually move to something more complex, like this. For every start, it's hard, and you have to have some starting point to know how to learn things. In Android, we can always start from the latest thing that Google has provided us. And in this moment, that is property animations. Property animations are a very powerful framework, and they are not restricted only to views. So you can animate actually any object in your code. You will use that in some edge cases, but it comes in handy. They are value-oriented, so every object you represent on the screen is combined of set of properties which are basically values. So it's logical that you have a value animator that provides basis for your animations. I mean, you change the value, the property of the object, and you get the motion on the screen. But the value animator doesn't have a target. It works with the basic information. So you have start time, start value, end value, and duration of the animation. And with these three information, value animator can provide the animated value at a certain amount of time that the animation was running. And the bottom part, so the object and properties, is your responsibility. So you need to manually set the value that value animator provided to the object or multiple objects you want, and you need to determine which property you want to use. To overcome this issue, you can use object animator, which basically extends the value animator we talked before and adds the target and a property. In code, it's simple. Here we have an animation that goes from top left corner and translates your object to the bottom right. And with object animator, you need to have two animations because translation X and translation epsilon is a different property on your object. And we can take a look at only one to see how object animator is defined. So if we read from left to right, first you have a type of your property. Then you have the target object, which is animated view. Then you have the property itself, which is defined with a string. You have start and end value, and you have duration. That's every information that your object animator needs to make a motion on the screen. But let's get back to the property. You see here, we got string that defines our property. That means that you have to have extra methods on your animated object, which are formed like getters and setters. So the name and the type must correspond with the things that you define while making an instance of your object animator. If you miss something, so if you misspell the property name or anything else, your animation won't run. You will not see any movement on the screen, which is bad, and you don't want to have that opportunity to make a mistake just by typing the property name. So there's something else, something better. That's view property animation. With the view property animation, we have optimization that you can animate multiple properties at the same time with the same animator. So you don't have to create two instances. And also, you can directly access important properties of your view. So this looks really nice. So you can create an animation in just one line of code. And this is something new. I hope nobody has a problem with SDK 11 and below, because this is available from there and up. But let's take a look what was before this. Before this, we can say it was a dark age for animations on Android. And that's the time where we had the most fear. But in every dark age, there is some light. And on Android, that light is called view animation. View animation have only 4 types of animation you can do in your application. And you can also combine them into some set. So you can change the opacity of your view. You can change the size, make it larger or smaller. You can move it around the screen, or you can just change the angle you're looking at it. And in code, it is simple, but you need to write a lot of code. You need to make the instance of animation. You need to define arguments. You need to set duration, and you need to start that animation on the object itself. The cool thing about this is you have value interpretation type, which can be absolute, relative to self, or relative to parent. This can come in handy when you're doing animations like, for example, sliding the view of the screen, because you can use points relative to the parent, and you don't have to worry about parent height or anything else, which is cool. But note here that we have fill after set to true. This is because view animation doesn't invalidate the view bounds. So it only changes the way that view is rendered on the screen during the animation time. And if you wouldn't set the fill after to true, your view would just go back to the original state and original position. And if you want your view to stay on that same spot or be the same size or whatever you did in your animation, you need to set fill after true. And the same problem you have when you move your object and you have some click listeners on them. You need to click the original position, not the position that you're currently seeing it, which is a problem. Also, as we got the property animations, some people are talking like, okay, view animations are deprecated. This is not true. They are not deprecated, and you can still use them. There is no reason why not to. And of course, there is no reason why you should refactor them. If you have something working in your application, don't touch it. Simply use it. If you have some issue, then you can think about refactoring or changing the way you are thinking about your animation. And don't be afraid of using view animations. Of course, try it with property animation before you try the view animation, because it's much less code and it's easier to use. But if you're stuck with view property animation and you don't know how to implement your animation, take another look at view animations, and maybe those value interpretation types will help you create the animation you need. So now we pass all the frameworks that are basic for Android and making the animation, and we can recreate some of our own animations. And we want end result to be almost the same. So first thing we need to do when we start recreating some of the existing animations, we need to determine what's happening on the screen. So we see that there's some move and fade of the first text, then we have a move and fade in of the second text, and at the end, after some offset, we have scale and fade out of everything on our screen. So to make animation, you need to have a layout. And if you do view animations, which don't invalidate your bounds, it's very important to think about the layout first, because making changes to your layout could help you make better animation, so it will be easier. For instance, here, I didn't use a linear layout because then my second text would be completely below it, and when I translate it to the original position, and then I want to do a scale, he will go back to his original position, which is below everything, and scale from there, not from the translated position. Now, I have it positioned right where it should be after the animation, and I will make the animation start from the point I want to. So let's take it one step at a time. First, we need to move and fade out the first text. This is the animation we're going to use. So we have to make some translation, some alpha animation, and then combine it in a set. Okay, nothing hard in that. And there's a bunch of code here. Next, we need to fade in and move our second text. So note, here we have a different translate animation. I'll move back to first. So in first, take a look at the last two lines defining translate animation. You have a relative to self value interpretation, and you are starting from 0 point, which is current position of the view, and you are translating it up because we have a negative translation over the vertical axis, and it will go up. Here, we are starting from 0.5, which is 50% of the view's height below, so going down on the screen, and we are animating it to the original position. At the end, we will need to have scale and fade out of both views currently visible on the screen, which is logo and text. We could reuse a scale animation here and make just one set, but if we would do that, we would have the same pivot for both views, which would make them, as they go larger, interact with each other, so they would collide. In order to avoid this, we made different pivots for the scale animation. You can see that logo will scale so that pivot is at the bottom of it, and the text will animate as the pivot is on the top of its view. So that will make views scale and not touch each other's. But we have more code. And to start all of this, we need to add some listeners so that animation go one after another, and we don't have the breaking animation. And ta-da, it will run. But it's a lot of code. It's hard to write this. It's hard to maintain this. It's hard to get to this point. And if you choose to go with property animation, it can all go into one slide. So there it is, the same animation implemented with the property animation framework. Here I'm missing the listeners and everything else to combine this, but it's not much of the work. It's just implementing the interface and moving parts of this into the on-end method of the listener. And you have the end result. It's almost the same. It's not perfect, but with some extra work, with some more tweaking, you could make this animation look almost the same. And here we are using only durations and positions for making the animation. In the real world, everything obeys rules of physics. So we call this natural, because everything is smooth and fluid. We want that in our apps. But we have few issues. First, our animation model is defined with start point, end point, and everything in between, so all the points in between. And we can make a path just crossing those points. But to incorporate some rules of physics, we need to have other ways of going from the one point to another. And if we look at these paths, they are different, so we could have different running time, which on Android we don't want. Our animation has fixed duration, which we define when we are defining our animation. So we need to think about some other mechanisms to overcome this issue. That's why we have interpolation. Interpolation is basically time function, which on input you have a elapsed time fraction, and you need to map the values that your property needs to obey. And important thing to note here, you need to obey the starting and start and the end of the animation, because you don't want to define starting position to be 0, and then that your animation starts with some offset. Your animation needs to start, so it means that your method get interpolation when it gets input 0, returns to 0, and when it gets input 1, which is the end of the animation, it needs to pass on the output 1. Everything in between is up to you. Actually, not everything, because you need to think about that your function that you are implementing must be smooth. You don't want to have spikes or something like that, because that will feel on the screen like you missed some frames in the animation. The red function is the default one. It's linear interpolation, which directly maps input to the output. But you can have acceleration, deceleration, and all sorts of interpolators to change the way your animation feels. Also note, you are not restricted with start and end value range. You can go above and beyond it. In this yellow example, you're seeing overshoot interpolator, which goes over your end position and then slowly comes back to it to finish the animation on the right spot. And we can take a look at few of these interpolations how they tackles your animation. This is the default one, the linear. Acceleration makes your view go slower at the beginning, but as it's reaching end, it will accelerate and reach the end position at the same time as linear interpolator. Decelerate does the opposite thing. It goes slower, it goes faster at the beginning, and then it just waits for the other views. To see this better, you can watch them run simultaneously, and you will note the difference. Android provides many implementations of interpolators. And to make a visual guide, I put here something that Amanda Hill created, and it's great. You should definitely look at it, and you should try interpolators yourself and see how they modify your animation. Now, you have almost everything that you need for starting to work on your animations, and you can move to something more complex. And when you are seeing a complex animations for the first time, you will not know what to do, and you will slow this down. Just so you can see every bit that is happening on the screen. And once you see this, you still could be not certain what to make out of this animation. It's because it's hard to decompose some complex stuff into simple animations and work with view animations or property animations. So on Android, we have our master card. It's called Canvas. So you can make custom animations on Canvas. Basically, you can draw your view and any object in that view. I will not show you how to draw anything on Canvas because it will be too much for one talk. I will show you how to use Canvas and make your custom animation. So things you need to have some time variable, and you need to be able to determine elapsed time of your animation. Based on that, you need to calculate all the positions, sizes, colors, and everything that's important for your object, and then you draw them. Then you rest for a bit, just to make sure that it's rendered on the screen. Then you do all over again. So how to do this? We're not going to use view object because we can make drawable, which is reusable to any view at all. Just set it as a background or something. So first, we're going to extend the drawable. And note, important, we are going to initialize all our resources in the constructor because we don't want to create paints and everything in the draw method. That will be very slow and your animation will be junky. So next thing is we need to animate this. So we are going to implement animatable interface. And in start method, we'll remember the start time, which will provide us an information which we can use in a draw method and calculate the elapsed time of the animation. And the last thing we need to do is we need to invalidate our view and schedule it to draw again after a certain amount of time. Here you want to make best out of Android, and you want that frame delay to be something that will render in 60 frames per second or something close to that. And again, we have our animation. This animation is done on canvas, so it's completely animated using draw objects on canvas. And you see here that we have different colors. We have different lottery numbers types. So this is highly extensible because everything you do in your code, you can make something more, just a small bit, and you have a different behavior, or you have different colors, or anything. But when you start working on canvas, you're entering the world of computer graphics, which is hard. I mean, you need a lot of math to cope with this. I mean, really a lot of math. You need to know some basics of geometry, algebra. Anything that you know on math will help you. And you could get afraid of this. But don't be. Sorry. Don't be. You don't have to be a genius and know everything about math, solve Enigma machines or something like that. You can take a look at math as a tool. So if you only have a hammer, you will treat everything as a nail. And you cannot solve every problem with a hammer. You need to have various tools which you need to learn how to apply on a specific problem to have the best solution. The same applies to math. So the more you know, the easier you can choose the right tool that you are going to apply to a specific problem. So what can you do right now? Don't slack on a math class. I mean, for some of you, this could be too late. So you can always learn and research as you do something with animations or with other things. And you can also search practical use of the things you learn at school, at conferences, or anywhere, which will make more motivation to learn more about them. One example, which I used on animation before, are polar coordinates. When I was learning this at college, I didn't know where I'm going to use this because it didn't make sense, that much sense at that time. And when I saw a circle in motion, somehow I realized, okay, knowing the right vertical and horizontal position of my views during the animation time is hard. If I translate this to polar coordinates and just change one parameter, which is angle that you are defining your object position at the moment, I can easily make a circle in motion. And translating from polar coordinates to Cartesian system, it's very easy, just one equation. After you have every knowledge you need to make animation, it's always good to make a routine. So I know that making animation is time-consuming. It takes a lot of tweaking, especially at the beginning, because you will not know which duration to use, which property to animate. You will have no motivation for it, because you will not see the benefit of animations in your application. And you will tend to always save that for the later. Just like testing. I mean, who has time for testing? But when somebody says, okay, just do another feature and don't care about design and animation, you should say no. Because right now is the perfect time to finish your feature with animations, with the right design, and you don't want to go back to it later. And as I mentioned, the first time you're going to start working with animation is going to be hard. you will lose a lot of time. You will use few hours to make just a simple animation. But when you see the final results of your work, you're going to be happy. It will be nice, and you will want to do some more. And after a certain amount of time, you will become a pro. You will become professional with doing animations. And you will make a routine. So you will not think of this as a problem. You will think of this as a part of your feature. And it will come to this, that you have once in a lifetime experience where you get your animation from the first try. So you get all the derivations, all the properties, all the interpolators. You get everything from the first try, and you're satisfied with your animation with the first test on the real device. And you will be the happiest person alive at that moment, because you made your animation with matters of just 5 minutes or even less. And when you were just starting to work on animations, this would take you a few hours. And at that moment, you will enter the rampage mode, and you will want to animate all the things, which is essentially bad. I mean, who wants to animate everything? This will give your app a bad performance. You will distract the user. I mean, nobody likes that. You need to have a meaningful motion, and you need to know what to animate. So screen transitions are one thing you really want to animate. And when it comes to screen transitions, you can do basic things, like just revealing views on your activity. But every Android version has a different activity transition. So if you want to make your app consistent on each Android version and each Android phone, you would like to override those transitions. Or if you are experienced enough, you can tackle them with custom transition or shared transition element, which Google provides. For all of this, or most of this, you will have to define your animations in an XML, which is not that hard. I mean, it's almost the same as you're writing the code, but APIs that are using these animations require XML. It's always good to animate new informations coming or going from the screen, because that will not confuse the user when did this appear and how will I use it. Long-running actions. I mean, you don't want your user to wait on a blank screen. And not every animation is strictly time-based. I mean, when users are interacting with your screen, it's always good to provide meaningful feedback. Animations are great for that. And of course, every app has some boring screens, like onboarding, about the app, and stuff like that. So why not make it more fun and put some small animations there? But the big problem lies with long-running actions. Every app has it. So you want to provide some loaders. You want to provide them for every long-running action, like waiting the response on the server side, fetching the large amount of data from your database. But the problem is you are not certain how long this action could last. It could be an instant action, like this. And then your screen looks like it's flicker. So you could think that you have a bug with your animation or something, and you want to avoid this. How to solve this is really simple. You don't have to show loading right away. User will not go off the screen if he doesn't see something for a very short amount of time. And if the data comes before you want to show the loader, you can show the data and it will feel instant. But again, if you are delaying something, you could get to the same situation that your data comes right after that delay pass. And you have the same situation. So what to do then? Be sure that if you show the loader, then you show it for a certain amount of time. That way, user will see, okay, something is going on, and no matter if the data came early, just delay this for a bit moment, and then show the data. Nothing will come to its end, because user will have his data after half a second or a second. It will not be blocked that much, but he will have a nice UI. And having the loader is very simple. You have this native implementation, which applies your theme, so you have a good color of it, and it's consistent with your app. But sometimes you want to make something unique, like this one. And this is rather easy to make with the animations we learned so far. But sometimes designers could go crazy and create something like this. And you could make this on your canvas. It will take a lot of time because you will have to figure what's going on here. And we want something better. We want a designer who made this to do most of the work. And we can go to him and say, OK, you send me this video. I don't know what to do with it, or a GIF file. It doesn't really matter. Give me the frames so I can see what's really happening. But you will not actually just see. You will use those frames in a drawable animation, and you will do a lot less work. But the problem here lies that if the designer changed the implementation, you need to change all of your frames, all of the durations of that frames, and this can be tedious work. So we want more. That's not enough. We have Lottie. This makes designer do all of the work. So he makes the animation. He must use Adobe After Effects, but that's not our business. He will learn that. And he just exports these files and gives it to you. So you basically have a JSON animation, which describes with some images. You don't really care about it. You just use these assets and run the animation in Lottie view. And that's perfect, I mean. But it has some downsides, and you have to convince the designer to use it. One of the problems that we could have using animations is timing. So what's the perfect duration of the animation? To know that, we need to know how humans work. So we need to have some engineer model of human performance to know what fits the need. And we could have a look at human processor model, which has some values on how humans perceives visual information. And just by looking at this number, we could reach some conclusions that times around 100 milliseconds could be regarded as an instant for most of the people. And something above 200 milliseconds could be a very quick animation. And we want to be quick, but we want to be readable. That means we want the user to notice the animation, to have a fluid and meaningful motion, but we don't want to block him. Also, one problem that we could have when we are developing animations are syncing multiple objects moving together. And natural reaction would be, OK, we can delay or offset some of these animations and have them run in sync. But actually, what could happen is that Android is doing a lot of stuff in background, and prioritizing your animations, it's not the first thing he wants. So you will need to use some listeners to sync your animations over the runtime. But the most important one, on update, which is great to use, is available only on SDK 19 and above. So you have to figure out some custom solutions for this. You can use Value Animator, which essentially gives you the update listener, and you are responsible of setting those those values to the object and to the right property. You can use animation sets, which then takes care of synchronization itself, or you can just extend the animations or create your custom ones. So we are reaching the end of this presentation, and I don't have any more smart things to say. I can just say that you're dealing with a design, and if you're working on something really long, you're not going to be objective about it. So every person has its opinion on the design. Design is not actually a science. So every person can have a different meaning what's beautiful and what's ugly. So it's always good to show off and to ask your colleagues what they think about the work you have done. But be prepared to get some negative feedback, because negative feedback is what really drives us to improve. I mean, positive feedback is always good because you know that you did something right, but with negative feedback, you have stronger impact to changing things. And over the time, you will need to know how to filter out the things, because every person has its opinion, and it could matter, but you need to start and have the majority of people happy. And the last thing, really last thing, is work in a team. That's the best thing you can do. You can surround yourself with smart people, and then when you are stuck, they can help you. Also, you can help others. It's always good to see other people's approach, and when you see something new, that's when you will achieve your full potential. So that's all from me. Thank you, and I'm open to any questions. Questions? Yeah. Just a moment.
Sorry.
Hi, thank you. You mentioned testing as something you do maybe late or never. Would you ever test your animations?
Yeah, but only manually, because it's something that you must see and feel.
Yeah.
It's not something that robots could do, at least for now.
Thanks.
So I am relatively new to the whole Android thing. So just my main question, what would be a good, for example, resource in your resource or something to read about, to understand more about how animations work and how to apply them on every level in your user interface?
You could always read the Android documentation, which is extensive. But the best way is to see what's out there, to see what animations you have, and just to try it out. And if that's not enough, you could always search for some blogs and blog posts of probably designers, because you need to know what to animate and how to animate, and then it's easy to transfer that to a code.
Yeah.
That's the easy part. But you really need to know what's a good animation and what's meaningful motion. And you can always take it to material design, because it's a good guideline on how your app should look and feel.
Yeah. Okay, thanks.
We have the question here.
Thank you. On the example for the view property animation, you use view.getHeight. Any recommendation where we should init this animation? Because if we do it like in onCreate or in start, the height will be 0. So any recommendation where to start these kind of animations to work properly?
If you do that on the onCreate, you can always use global layout listeners to make sure that your view is laid out, because if it's not laid out, you don't have anything to animate. Also, the one thing I didn't mention when you are creating the layouts, when you want to have something not visible at the first moment and you want to enter it later, you shouldn't use visibility gun, because making visibility gun will make your view not pass the measure phase, so it will not have any height. But if you use invisible, it will get measured, it will not see on the screen, and when you do animation, the animation will run. If you use gun, because it doesn't have any measure, you will start animation, you will see the end value after a certain amount of time, but you will not see any step before that. Thank you. Anything else? Cool. I have some stickers and t-shirts for those who ask questions. Is there any more question? Here it goes. Good motivation.
Will you be making the slides available?
Yeah, I will post the slides. You can follow that on Twitter.
First of all, thanks for the talk.
Thank you.
Do you use some other tools beside Lottie?
I don't use Lottie. I mean, I use Lottie in Android, but it's library. It's not tool. Designers use other tools. You mean while designing the animation, or?
Designing the animations and libraries you are using for your animations.
Yeah, I'm not really designing animation. We have a design team for that, and they are using Adobe After Effects and all sort of stuff to really show us developers what they want to have in the app, and then we can discuss if that's possible and how it's possible. So I cannot really answer the question how to make good animation, because I'm not a designer.
Okay, thank you.
Hi. I'm also interested to understand how you work together with designer so the workflow that you use actually, because I find a big issue here to be able to work together, because as you said, there is nothing that from Adobe After Effects, for example, give the way to output automatically some animation in Android Matter. So how you can solve this issue during the workflow with your designer?
First, when we start working on some project, design is the first thing that goes to the client or to anybody. But important part is that you make everybody engaged at those first moments. So even the QA team, even the developers, because actually designer could make a pretty good design, nice looking, but for you as a developer, it's not possible to make those. And you need to act quickly. So you need to tell him, okay, this is not possible. The same applies to animations. Designer will make his first attempt on the animation, then you will see it, then QA will see it. The more people see the animation, the more feedback you will get, and you can start iterating to the final animation you want. And it's easy when you have designers next to you, because it's very quick feedback, and you will end up with animation that's not so hard to implement, that is meaningful, that provides something extra in your animation. Does that answer your question?
You don't have any other tools to integrate?
We use InVision and some prototyping that that designer can show to the client, and the client can really say, okay, this works for us, and so that we can really take a look at how it would feel in the real application. So some prototyping like InVision and itself can come in handy.
Okay, thank you.
Yeah.
Do you have any tips for convincing busy designers to focus more on the animations? For designers to focus more on the animations?
Yeah, go through the material design, see what you should animate, and then just, if developers are lazy or afraid of animations, make them start working on them. That's the best. So you need to make an example and say, okay, Google made material design and they are recommending something. Why aren't we having that in our apps? And you can be the first Ignite that makes your app look better. You are the designer. You need to have your signature on the app and say, I designed it. I designed this animation. This feels awesome. Yeah.
Any tips on debugging?
Debugging the animation.
Yeah, when it doesn't really work the way you. Any tips on debugging when it doesn't really work the way you expected it to work?
Yeah, you have developer
Apart from
tools.
setting it to 10 seconds. Or
Yeah, I mean, you can do that, but also you can use developer tools which can make your animations on device run for longer, so you don't have to do it right in the code. You have developer options that can really invalidate your bounds to see where exactly are you rendering something. This can be useful for the animations also. So use the developer tools. And also, if nothing helps, you can go and add your interpolator and see what's the output of the animation and where are you doing something wrong. And if you do have something custom, it could be that you are dividing something with an integer number and you're not giving the right value. It happens to me a lot, and something like that. So it's basically experience that will drive you to make better animation and to easily debug and fix things.
Yes. When you have complex animations and you want to animate many elements, let's say, that happen one after the other, do you prefer to use on start and on end, or do you prefer to delay the start of an element so that it could meet the time of something else?
Yeah, I understand. It really depends if it's really necessary to have them run one after another. You need to ask yourself, okay, what will happen if this view starts a little bit before the first one ends? If nothing wrong could happen and it's okay with you, use the delay. But if you really want to make sure that you are animating a second view after the first view, use animation listener. or create your custom animation, which will incorporate one large animation and start the views one after another. It's done. Okay, you can see me. I'm here till the end of this day, so feel free to catch me up.